Okay.
If you were 10 years older.
I think it's recording.
Oh my God.
Yep. Do you want to hold it, or do you want to just put it on the table? Because it can just be put.
Well, it won't be very steady if I hold it.
It's been like an hour-long birthing video.
Will it
That's where I learned this.
Does it just need to see the TV, or?
They can see me in the TV. I think that's probably good.
I'll tell you.
Okay. And you can't see nothing.
That's right.
Oh yeah, the second time.
Oh, the lighting stuff
Yeah.
is where the camera, which goes out.
You are ready. She's all ready. Good at getting up on the chair.
Thank you.
I can't really see that far away. Is it capturing things nicely? Should be a little bit farther over and fully capture her, right? Can you just move it in that direction? Although the
Is there enough lighting
I love
in
it.
there?
you can't, the screen just looks like a white blotch though.
Won't the resolution be better once you're... Well, it's the whole lighting issue where it's just
Can you
glaring.
turn off those lights a
Yes,
little? We'll
sir.
see if we can make it so it's screen.
No,
Yeah.
what about these ones?
That's just as
Wouldn't
wide.
that help?
Whose spot was
I'm
this?
checking for something.
Right.
Yeah.
Does that help at all?
Do you have books or something to write on?
We need this
Yeah.
lid on.
Oops, I don't want to close that.
Something's flashing red now.
Is it the
It's
battery?
there's the recorder. It means that it's recording.
Okay.
Oh, he's got it. So it's just gonna be a blaring screen, I guess. Okay. It's been recording the whole
Don't
time.
be reading the book.
So indications of traveling pollutants in ice core samples taken from Greenland and Canada is what I did my research on. I used two main scientific papers, one done by McConnelly, and he looked at Greenland ice core samples from 1770 to 2000, and Osterberg looked at Mount Logan ice core samples in Canada from 8,000 years ago to 2000. And what I did, McConnelly focused more on that's the bread.
Oh, take the bread off.
You can just turn the oven off, I think, and it'll be good. I don't think it's been in there that long. Oh, Greenland focused more on heavy metal transport, so how heavy metals are transported, and Osterberg focused on a multiple spectrum of heavy metals and different elements that traveled. And McConnell didn't have anything to do with ice core samples, but he was looking at just how pollutants travel in general in the air. And so that was interesting to kind of compare some tables that I got. But these two I used raw data and came up with my own graphs, and I'm going to be comparing the information. So the first thing you need to understand is how pollutants travel. And basically what they do is they travel through the water cycle. They evaporate, get stuck in the clouds, and then because of the wind currents, the global wind currents, they travel up north. So they travel from down south to up north. And that's called the global distillation. And different pollutants actually travel differently. So heavy metals like lead will they'll just go to their destination and stay. But other pollutants will actually do what's called a grasshopper effect, and that's what you see here, where it actually stays in one spot, is re-evaporated, and then continues moving on. So these two samples are the two papers I looked at. Like I said, took samples in Greenland. It was like Act 2 up in here, and then Mount Mount Logan is in Canada, right by the southeast border. And in these two papers, because of the wind cycle, the global wind currents, it's thought that the pollutants had come from Asia over into and were deposited on Mount Logan. And for Greenland, they came from America wind currents and Europe wind currents. So glaciers are pretty reliable for information because they've been around for so long. They do wax and wane. Like sometimes they're advancing, sometimes they're retreating. But there's actually a line on the glacier that scientists have found, and where it's almost always accumulating on the glacier. And the ice core samples were taken above that line called the maximum accumulation zone. And so for the Greenland core sample, like how do they date snow, right? What's in snow to date? Well, they can actually use elements found in the snow and say there was a high amount of oxygen 18 or a high amount of oxygen 16. By knowing that different ratio, they can actually tell what date it is because the Earth has its own natural cycle of oxygen isotopes, or they can use carbon. They have like a natural carbon amount that's in the atmosphere, and they use that to date it. They also use volcano ashes because the volcanoes will erupt and settle on the glacier. So how do they actually take the ice core samples? They how does that work? There it goes. Okay, so they use a electromagnetic drill, and you can see in Greenland they drilled 115 meters deep, and Mount Logan they went 186 meters deep, and they packaged the sample. And here is a short clip just to see. This is just generally how it's done. It's done different ways, though. And there isn't really any sound, I don't think.
Where are they right now?
This is actually in Antarctica. This isn't in Greenland or Canada.
Is that like a really big igloo or?
No, they're in the snow right now. They
really?
dug that out. Yeah.
Oh.
950 meters thick.
This is quite an important period. 40,000 years ago, there was an ice age which they were in water by analysing the record of the climate from the bottom of the core to the top. And we have to see how we moved from a cold period into a warm period. And this helps us understand how we expect the climate to change over the next few years.
So again, how they tell like when a warm or a cold climate is they use the oxygen isotopes. And that's a little sidebar I could go into, but we'll try to stay on topic. Unless you guys really want to know about it. So some of the different particles that the studies looked at that traveled north was black carbon, non-sea salt sulfur, sea salt sodium, various oxygen isotopes, various metals, enrichment factors of the metals, so enrichment factors are how the metals lose protons and actually change. And then organic pesticides such as DDT, polycyclic aromatic hydrocarbons like fluorine, and chlorinated industrial organic compounds like PCBs. Those are just some common ones. There's a lot of uncommon ones that I've never heard of.
Black carbon, and it says PCBs.
Mm-hmm.
So all black carbon is PCBs?
No, black carbon is partially burned carbon, and PCBs are actually a well, it comes from plastic, from what I know of. So they're
That's
two.
kind of what I wondered. I've seen in Japan a pile of the black carbon in a refinery where they separate out the black carbon to use it to color the black cases of computers and things like that.
Oh,
So I was
interesting.
wondering if it was PCBs.
No, different. From what I understand, they're different. Yeah. So one major problem with this study is determining if the elements are natural or if the elements are man-made. So how they do that is they look at enrichment factors, and they also look at, they also compared not only enrichment factors from the metal, but they compared the black carbon. So if it was high in black carbon, then it was probably more likely industrial produced, and they kind of used all these different methods and compared them to determine if it was man-made or not. And this was interesting because McDonald, like I said, had nothing to do with ice core samples. He was just looking at how pollutants travel. And this is the ratio for lead, but I'll be focusing on lead for the rest of the slide. And they came up with 27 approximately of a lead flux due to humans. And Osterberg, which was another study that he did in Mount Logan, and he came up with a 25 flux for influence of.
What's a flux?
I'm not really sure. It's the difference between the human-made lead and the naturally occurring. That's my understanding of it. It might be more complex than that, but that's how I see it. So what was actually found? So from 1770 to 1870, in Greenland, their average concentration was 10.2. That's parts per gram, I think. Wait. I'm drawing a blank on that. But I think it's parts per gram.
Micrograms per gram?
Maybe, yeah. I feel really silly because I'm drawing a blank on that. Oh, you know what? That's the wrong. It's supposed to be nanograms per gram. That's why I don't know it. It's supposed to be nanograms per gram. So they determined that most of the lead concentration was due to natural occurrences, and there was a great spike. You can see right here around 1860, and they said that it might be a side effect of the Industrial Revolution. And during this time, BC concentrations were high, which means that we were burning coal during this time more than oil, which was interesting. So this data set is again Greenland from 1900 to 2000, and this was a coal-dominated industry in North America and Europe, and heavy metal concentrations were 5 to 10 times higher than in the pre-industrial era. This is, so you can see 1960 to 1970, you can see this little increase of lead, and that was the peak of America and Europe, Industrial Revolution. And it's kind of interesting because the Clean Air Act was introduced in 1970, and you do see a decline in lead concentrations greatly. Obviously, it's a couple years after, but we all know how our government works. Slow. So, and there were more stricter regulations later on in 1990. So in Mount Logan on Canada, what they found from the 1700s to 1800s was, again, most of the lead was just naturally occurring, not much really going on. But the interesting thing about this study, because it dated so many years back, was that there's actually a 250% increase in lead levels from 8,000 years ago to the 1700s. So I thought that was really interesting. And so this is the same Mount Logan from 1900 to 2000. And this is interesting because, again, remember Mount Logan is in Canada and the pollutants came from Asia. And the Asian Industrial Revolution was in the late 20th century. So you see this spike, and I think they're actually today the biggest coal industry in the world. So you see this spike. And here's just looking at the two data sets, seeing what they have in common, I mean. So both scientists determined that most of this is naturally occurring lead. And you can see, if I can use my cursor. You can see that there's a slight spike here and here, which I thought was interesting. And again, around 1860 on both graphs, there's a spike. And I'm sure there were, if you looked it up online, there's probably volcanic activity related to that and tsunamis. The other interesting thing to note is that Greenland's concentration of lead is a lot higher than the concentration in Mount Logan. If you look, like 20 times higher, yeah.
Is there any thought as to why?
I did speculate that more on my paper, and I came up with the fact that America and Europe, one, Greenland's having two industrial influences, and two, they've been around longer. Those were my two hypotheses. And Europe's also a lot closer to Greenland, so the pollutants don't have as far to travel. And then this is looking at comparing the data from 1900s to 2000, and you can see a spike around 1915 on both. World War I was going on then, so maybe it had some kind of an influence. It's interesting that lead was introduced to gas in America around 1920, but neither graph seemed to reflect that. 1920. Don't really see a big increase. And the other thing that was dramatically different was the decrease in Greenland and America. Well, Greenland, right, the pollutants came from America, and this is when the Clean Air Act and stuff was all being placed. Lead was getting taken out of gas. And on Mount Logan, you can see a huge increase during that time period. So who cares? I think we all know that lead's pretty bad for us by now. Surprisingly, 80 to 90% of human exposure to lead is through food, and how food is exposed through it is through the air. So we're seeing that these elements are traveling through the air by these glacier core samples. And the other bad thing about it is that it's being stored in the Arctic and stored in these animals that are at the top of the food chain, and just like every other bad chemical, it gets stored, right? And